The blue that you see is the graph. So here's my quadratic graph. We are going to learn two main vocabulary words today, kind of doing like the anatomy of a parabola. Okay? So we know the vertex.
How do you say it?
Parabola.
She said parabola.
Yeah, it's not parabola. Parabola. So we know the vertex here at HK. Y'all already know that. We're going to learn two new things. The first one is what is called the focus. The focus lies inside the parabola. So the graph always faces in towards the focus. The focus lies inside, in line with the vertex. Notice how they're on the same line. Okay, so this is my focus, right here. Let's take a brief pause and talk about how this is applicable in any way, shape, or form. Right, you always ask, how do they even use this in real life? No one ever does. This is actually pretty applicable. So, do you guys remember like the old school satellite dishes? They used to like sit on people's roofs and they have that like point out the middle. They like look like this. Good. Okay. You remember those? They look like that? Well, this is a parabola. If you look at those dishes, they have a perfect parabolic shape, where your vertex would be right in the back. So it's like a parabola on its side. This, the spot where all the signal converges, right, that like pointed out part in the middle, is the focus. Because everything that bounces off the satellite hits towards that focus. So this is an actual parabola used on something in legitimate real life, and it's applicable, and that's how they created these, was by using the shape of a parabola and utilizing what's called the focus. It's where everything focuses in. When you focus, when you bounce the signals off of the satellite dish. Okay, so think satellite dish, focus is that middle part of the satellite dish. All right. The distance between the focus and the vertex, this right here, is called P. Your distance is P.
Is there a lot of things to remember those?
Not really. Mostly it's P and your focus. Now, the distance between, if you draw a straight line across the focus, and you draw these points here, this right here is called your focal width, right, because it's the width of the focus, and that's equal to 4 times P. So this is P, this is equal to 4 times P across. Width means like wide, how wide is it? So the width across the focus is called your focal width, and it's 4P. Right? The other vocabulary words, we have two. The first one was the focus. The second one is what is called the directrix. This right here. The directrix is this line on the other side of the vertex. The distance between the vertex and the directrix is also P.
So we're going to need to find all of this?
Most of it.
So
It's
like,
not as bad. It looks bad for the first example. It's not.
But is it going to give us one?
You'll be able to find everything. So the distance between the directrix and the vertex is P. The directrix helps to tell you what direction your graph is going to face, because it always goes away from the directrix. My graph can never hit that directrix line. Okay, it goes the opposite direction. So the distance between here and here, your vertex and your directrix is P. So if you're given the directrix and you're given the focus, you know that your vertex is in the dead center. So if you have your focus, your vertex is in the middle, and then your directrix is equally spaced below it. Okay, they're perfectly equally spaced apart. Yes, sir.
So on your right, when it says like focus, and you try to find a P on it, would you have to add from the focus to that find that tree?
Yeah, so if you have the focus and the directrix, so say you have these two, and it's 8, let's say it's 8, you would know that the vertex is 4 away from each of those, because it's halfway, okay? Alright, speaking of that, let's look at this now. Now this part, you don't need to memorize all of this, okay? These you don't really need to memorize as much, because we're just going to do them on a graph. You don't need to memorize these like formulas or anything. What I need you to focus on is the new equation. Okay, this equation is very similar to the one that you wrote in the warm-up part. Y equals 1 over 4p, x minus h squared plus k. What used to be where this 1 over 4p is? A. So it's just another type of A, but we're utilizing this p value, this distance between the vertex and the focus. So this was A, right? And we said that 4p was your focal width. So this version, this equation just gives you more information about the graph. All right, so we have the focus that's on the inside, that's p distance away from the vertex. We have the directrix on the outside, that is p distance away. And then we have our focal width, which is that 4p. All right. Let's rewrite our new equation. So we know our new equation is y equals 1 over 4p, x minus h squared plus k. Notice it's the same, it's just instead of a, it's 1 over 4p. And we're going to be able to graph just given the focus and the directrix. So they give us the focus, they give us the directrix, we're going to graph. Okay? We're going to write out our steps on graphing, so that way when you go to do an example, you're not like, I don't know where to start. Follow these directly and you'll be completely fine. So the first one, plot the focus. So the focus on this example is at 0, 3. So we're going to go plot 0, 3. And I'm going to label it with an F for focus. If you don't label it, you might mix it up with your vertex, so I would label it. That's step 1. Step 2, graph the directrix. Our directrix is at y equals -3. So go to y of -3 and draw your line. You can draw it solid or dashed, I don't care.
Why'd you draw it? Because
I just do so I don't mix it up with my actual graph. So you can do it either. You can draw it solid or dotted. Okay, where do we know the vertex is?
above the,
It's going to be above the directrix and below the focus, right in the middle. So step 3 is going to be to put the vertex halfway between focus and directrix. So your vertex goes halfway between those two.
Is it always going to be in the middle? Like, always just
Always in the dead middle. So the way that I do that is I count and I say, okay, 1, 2, 3, 4, 5, 6. These are 6 away from each other, so halfway would be 3. So I'm going to go 1, 2, 3. And it's in line with the focus, yes.
Is it always going to be like another?
Well, always make sure that's a number you can divide by 2. I would give you 5, and then you have to go like 2.5.
appreciation.
So label it with a V, so that way you know which one's your focus and which one's your vertex. Otherwise, you will mix them up. All right, so steps 1, 2, and 3 are pretty fast. Okay, it seems like a lot, but it's just focus, directrix, put the vertex in the middle. Then we are going to find P, 2P, and 4P and write them out.
There's 4 feet.
You're just going to take P multiplied by 4. So if we go back up here, right, we know P is the distance between the focus and the vertex. We know that 4P is this total width. So what would half of this width be? 2P. That's why we're finding P, 2P, and 4P. So
we just multiply P by 2
mhm,
and multiply the 2 by
or the P by 4. So if my vertex is 3 away from my focus, 3 away from my directrix, then P is 3. So if P is 3, what is 2P going to be? 6. And then what is 4P going to be? 12. Okay, write that out every time. You just multiply by 2 every time, basically. 3, 6, 12.
In every problem?
Mm-hmm. Always P, 2P, 4P. All right, why do we do that? Because our next step, and then we're pretty much done, is I told you the total distance on either side of the focus was 4P, right? That big width. So we're going to go 2P on either side of the focus to get 2 points. So the last real step to be able to graph is going to be to go 2P spaces, 2P on either side of the focus. That's why it's important to label which one's your focus. And then connect your points. So we're going to go 2P on either side.
So then why don't we need the first?
Because the 4P is going to answer this question. So go 2P on either side. So 2P was 6. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now we can connect our vertex to those lines. So do you see how this is P, right? This is 2P. This whole thing is 4P. The width, the whole width is 4P. That's your focal width. So what is my focal width?
4P.
4P, which is 12. Where is my vertex? 0, 0. And now we can write the equation. The equation was y equals 1 over P. Now, we don't have to make it negative because it's not facing down. If it were facing down, you would put a negative in front. 1 over the fraction. X minus h, remember these are h and k, squared plus k. So we have a bunch of zeros. Now, you can leave it like that with those zeros in there, but on like a multiple choice test, I guarantee those zeros will be gone and you'll see it like this. So your job now is to take 30 seconds and talk with the people at your table through each step of this graphic. What did we just do? From beginning to end. Talk for 30 seconds. 1. I want you to plot the focus, the directrix, and the vertex on this one. So plot the focus, the directrix, and the vertex on this one. Yes.
Oh.
Square root of it. Okay. No, that's pretty much all there is. And then on Monday, the Parabola basis.
So then what
So you'll have your, on Monday, you'll have like your vertex and your focus and your directrix over here in your graph. So it'll literally be the same thing, but just like this. Alright, let's check. So your focus is at 0, -2. Label it. Your directrix is at 2. So your vertex should be halfway in between at 0, 0 again. It's not always at 0, 0, just for these first two. What direction is this graph facing? Down. It has to face down because it has to go towards the focus, away from the directrix. Okay, so we did the directrix, we did the focus, we did the vertex. Now what's step 4? Find all the P's. Yes.
Let's say that the focus were to be on top of the curve. Would it just be a no station?
Then it would be facing up. So if the focus was here,
Yeah.
then your vertex would be in between here and it would be facing up.
I know, but like, let's say you try to trip up.
It won't. I won't have it in front of you. What is your P value?
2.
2. So what's 2P?
4.
4P? Okay. What do we do with that now? Like we have that, what do we do with it?
You do it from the focus.
Yes. You go 4 on either side of the focus.
And you connect it to the vertex.
So I personally think that this is easier graphing than before. Remember before you had to find the vertex, you have some symmetry, you have to plug a point in, and you have to flip it to the other side. I think this one's easier than that. It requires way less. This is the only math you have to do. Okay? Alright, what's the focal width? 8. Remember your focal width is your 4P. Where's our vertex? 0, 0. So our equation is y equals, what do I have to put in front of the 1 over 8? Negative 1 over 8. X minus 0 squared plus 0. So you could also see this written without the zeros as y equals negative 1 over 8x squared. I will take it either way, but multiple choice, you have to see this. Alright, I'm going to give you 2 minutes on the next one. The next one, the vertex is not at the origin. So 2 minutes, try and work it out with the people at your table, and then we'll go over it. So if your focus here is at negative 1, 5, and my directrix is at negative 3. My vertex needs to be in between these, in line with the focus. Don't put it on the origin. In line with the focus. Alright, keep going. Okay, let's keep going on this one together. So we plotted the focus. We plotted the directrix. Let's bring it back together and do this together. So turn your voices off. Alright, to get the vertex, you go halfway between the focus and the directrix. So these are 1, 2, 3, 4, 5, 6, 7, 8 away from each other. So to go halfway, you need to go 4. So that puts me right here. 1, 2, 3, 4. 1, 2, 3, 4. Here's my vertex. It's at negative 1, 1. Alright, what is my P value?
4.
So 2P
8.
and 4P.
16.
Beautiful. So 16 I know is my focal width. I'm going to go 8 on either side of the focus.
Is that necessary?
Which part?
The
8 on either side?
Yeah.
Yes, because otherwise, watch, I could have drawn this like this. Right, and that's not the same as the correct graph that goes through here. So that's why. So I'm going to erase that. So the whole point of doing that is to make sure your graph is as wide or as narrow as it is supposed to be. And now the equation. This graph is facing up, so it's positive 1 over 16. X minus negative 1, so x plus 1 plus 1. Remember that h value switches?
How did you do the customers?
These. So h and k. H and k. Remember it's x, you switch the sign of h. Alright, before I turn you loose on the last two, I want to talk about a couple things. So go down to this blank space that you have right here. I'm going to show you something that has to do with the equations because it shows up on your DLA. We will talk more about it on Monday, but I just want you to see it for right now. So our equation is y equals 1 over 4p x minus h squared plus k. This could be rearranged. Okay, if I move the k over, I have y minus k. And then if I multiply by 4p on both sides, so this and this are the same, just rearranged. Okay? The reason I show you this is because we like this one, the top one, but you could be given this bottom one. It's very easy to rearrange. For example, if I'm given 12 y minus 3 equals x minus 2 squared, all I have to do is divide by 12 and then move that 3. Okay, to get the more preferable type. Yes.
Can we still do the one you tried?
Yes, no, I want you to use this one.
Okay.
I'm just saying on like multiple choice you could see this. Yes.
But for the second one, can we move the k to
If you move this k over, you just go with this.
So
like
same.
Yeah, so like look at number 5. You would just move that 3 over and then you have the same equation. The last thing I want to point out before I let you start working is if I'm given, let's say that I'm given the directrix at y equals -2 and the vertex here at 0, 0, whatever. If you're given the vertex and the directrix, you can find the focus, right? Because what is this distance here? 2, or p. So the focus is going to be 2 up from that, right? So use kind of your problem solving skills if you see something like this. Did you know this is also?
Taking a deal like for
We haven't talked about it yet.
No.
All right.